Hello team, welcome to this video where we look at solving simultaneous equations with more than two variables. So our success criteria to perform this, and it's slightly different than when we had the more than two variables in the previous exercise, and it'll become a little bit more apparent, is we're not looking for when we have just two equations and when two linear equations that are just lines, and when they cross, that these equations could be planes or greater than that. So we're sort of dealing now with three-dimensional items and points of intersections of three-dimensional items. So our success criteria is to solve three simultaneous equations when you have three variables, and then solve three simultaneous equations or less than three simultaneous equations when you have three variables and there's an infinite amount of solutions. And I'll show you what that looks like in a little bit. So for example is solve the following system of equations, solve the following system of simultaneous equations. And you can see that this time we have three simultaneous equations and we have x, y and z as variables. So it's a little bit different to the previous exercises where we had x and y and then b as a placeholder, where we're now dealing three-dimensionally instead of just a straight line graph in two dimensions. So yeah, let's get straight to it. So it's pretty uncommon to actually have to do this by hand. Actually really uncommon to do this by hand in the Year 12 exam. It's almost always only comes up in the Tech Active one. So as soon as you've got three equations that you need to solve for in its Tech Active, just put it straight in your calculator using the solve function. But we should practice, at least wrap our head around what our methods are to do. And we use the similar sort of methods of elimination or and substitution to solve these. It just is a little bit more tedious because a bit more work. So we've got equation 1, equation 2, equation 3. And as it says here, try to use one equation to eliminate the same variable from the other two equations. So we want to use one of these to eliminate variable from the other two. Now, to me, this screams the fact that there's a single z, and then 4z, no fractions there at all so far. I'm going to use z to eliminate, and I'm going to use equation 3 to eliminate z from the other two equations. And then once we have z eliminated from the other two, we're then down to two equations with just two variables. So I only have x and y in it because we've eliminated z or z, and then we can go on our merry way. Solve like normal. So I'm going to do equation 1 take away equation 3 to start with. So I have 2x plus y plus z equals 1. I'm going to take away 6x plus z equals 8. And I've sort of just lined up the variables to make it a little bit easier. So I'm taking away all of that. So I get negative 4x plus y is equal to negative 1 take away 8 is 9. And so I now have one equation. I'm going to call this new equation equation 4, which is a version of equation 1. Turn that into equation 4. I'm now going to do the same thing to equation 2. So I'm going to do equation 2 take away, and I'm going to use the same equation 3 again, but I need to multiply it by 4 because of it's only single z and we've got 4z in equation 2, so I'm going to take away 4 times by equation 3, and so that looks like 3y plus 4z equals negative 7, take away 4 by all of 6x plus z equals 8, and I might actually put that 4 inside. Show you what to make it more useful. So we're doing 4 times by this. So 4 times 6 is 24x plus 4 times z is 4z, and then 4 times 8 is 32. So we now get negative 24 4x plus 3y because we've got our original 3y, and then the 4z's cancel, so then we get negative 7 take away 32, that will be 39. So we have now converted equation 2 into what we'll call equation 5. So now we have two equations just with two variables in it, so we're back to regular solving simultaneous equations. We have a 4x plus y equals negative 9 and 24x plus 3y equals negative 39. I'm going to rearrange equation 4 to get y by itself, and then I can do substitution to solve instead of doing elimination. You could multiply equation 4 by 3, and that would make you 3y and 3y cancel out, but I'm going to rearrange equation 4. So I get y is equal to negative 9 plus 4x. I'm going to sub into equation 5. So I get now negative 24x plus 3 by negative 9 plus 4x 9, and now I just need to start solving for x. Negative 24x minus 3 9 is 27 plus 12x equals 9. So I get negative 12x I'm just collecting the negative 24x plus the 12x, collecting like terms. Take the 27 over the other side, so add 27 to that side is equal to negative 12, because it's negative 39 plus 27, so x is equal to 1. I can now sub x equals 1 into equation 4. Since it's just got x and y in it, that'll tell me what y is. I get negative 4 by 1 plus y is equal to negative 9. So I get negative 4 plus y, 9. So y is equal to, add 4 to both sides, I am with negative 5. And then I need to go back and find my original z, so I'm going to sub, again, x equals 1 into equation 3. Get 6 by 1, z equals 8. I get 6 plus 8, so z is equal to 8 take away the 6 is 2. So my final solution is x equals 1 there, y equals negative 5 there, and z equals 2 there. So it's just this first bit up here, that's the new bit. Use one of the three equations as an eliminator for the other two equations to get rid of one variable, and you need to get rid of the same variable. There's no point using equation 3 to get rid of z in equation 2, and then using it to get rid of x in equation 1, because you're still left with 3 variables. So yeah, that's how you go about it. Here's how you do it on your CAS. From the Math 1 keyboard, just like with matrices, this is our multiple equation, or the simultaneous equation function within the calculator. It normally only gives you 2 simultaneous equations, just like the matrices. Tap it again, and it'll add another row to it, and you get 3, and you could enter it all in. And you make sure you use the variable section of the keyboard and not the alphabet or the standard letters, as it won't calculate as it says down here in the exercise. Please just do 1 or 2 by hand, and then the rest you can just do by CAS. It's actually important to do most by CAS because you want to become efficient at it. Right, so that's our first success criteria. This one, tick. Our second success criteria is when we have infinitely many solutions. Now, this occurs when no matter what you try, you can't eliminate that third variable, and it ends up just sticking around as a placeholder and acts sort of just like what happened in the previous exercise, where we have infinitely many solutions. It's when this situation adds up where it's not just a single coordinate, because that's what we've had here. Is we could imagine those three equations are actually three planes in 3 dimensions. They're flat surface, imagine pieces of paper, and then what happens is having them all together, there becomes a single spot where they cross over in 3 dimensions. That happens at x equals 1, y equals -5, z equals 2. In these situations here where there's infinitely many solutions, is the way those planes line up, it ends up that the solution could be a 3-dimensional straight line, it could be a whole 3-dimensional plane, so the z sticks around and we end up with what's called a parameter. As it says here, this parameter, it technically can be any number. Just like before when b overlapped as a straight line, b could be any number for infinite solution. We have this, it's just going to be z instead of b, whatever else. The textbook likes to use the symbol lambda as the parameter or placeholder for infinite solution. But you can keep using z, you can use lambda if you want. It's going to work out the same way. You won't have to do these by hand. It's just being aware that when you do it on your CAS and you get a solution that still has a z in it, still has a z in it, still has a z in it, you're just realizing, okay, this is an infinite solution. Write it as such. You can write it as z, or you can write it using lambdas. This can also occur when you're only given 2 equations and there's 3 variables. You just have to assign one of them as a parameter and pretend it's just a number in all your future calculations. So we will have a crack at this by hand just so you can see it. And I'll try and make this quick because we're up to 12 minutes. So I'm going to let z equal lambda. And it's probably helpful to not leave it as z but leave it as lambda because you won't confuse it as much. You might treat it more as a number than as a variable and not think you could continue with solving algebraically. So I'm going to do that. I'm going to call that equation 1, that equation 2. So I'm effectively left with 2x minus 3y plus lambda, which we need to treat as a number, equals 6, and negative 2x plus 3y plus lambda equals 8. I'm going to do, I've got a 2x and a negative 2x. This is, let's see how this goes. I'm going to do 1 plus 2. So it follows on x minus 3y. Have I copied this down wrong? Because this is going to get an error. 8. That turns to 0. That turns to 0. We get 2 lambda equals, say, is 14. That's not right. What's going on here? Wrong. I think I'm looking at this because the 2x is always going to cancel with negative 2x, and negative 3y is always going to cancel with positive 3y. So I'm thinking I've done something wrong here. We might leave this for now. You can certainly do it on your CAS. Chuck this one in your CAS and we can talk about it tomorrow in class. But that's it for today. And see you on the Zoom meet tomorrow.